Welcome to the Southern Africa Digital Relay Protection Conference. We will wait 1 minute to the rest of the attendees to join us. Meanwhile,
thank you all for your attendance, and thank you as well to all of you that are many to the other 2 sessions with Andrea Bonetti and Stefan Larsson. We are glad to contribute with our experience and knowledge to the community. Today, for me, is a pleasure to have Mario Spitzer, Technical Product Manager for Relay Protection Testing from Megger US. Before, I would like to pass over to Daniel Salate, who is the Sales Director for Africa, India, and Middle East, to introduce himself and his team. So when you want, Daniel.
Yes, thank you so much, Sylvia. And thanks to all the attendees. Very much appreciated that you're taking your valuable time, and we do appreciate it. You know, I'm from Switzerland, so in Switzerland we know that time is money. We cannot buy your time, but your money is already with us on the Swiss bank account. Megger is a global organization with manufacturing sites distributed all over the world. Of course, has a global approach. As such, you know, it's difficult to understand what is going on locally, and therefore we follow the strategy: think global and act local. And that's actually the part from the headline. Megger acts global, so it's not a typo error, it's a combination of global and local. And I would like to explain to you what does it mean in regard to South and Southern Africa. Could you press 2 times, please, Sylvia? So besides myself, as said, I'm the sales director, and I'm a couple of times a year in the African continent, if there is no pandemic situation. So to overcome such difficulties, we have Alan Goodson, who is permanently based in South Africa. He's traveling out from Durban, and he's responsible for all sales-related matters. Another 2 clicks, please. And then his counterpart is Nathaniel Folger. He's our application specialist, being based also in South Africa, traveling from Johannesburg. And he's making sure that he's giving adequate training to the equipment sold to our end users, that the end users can take biggest benefit out of the features offered from each individual equipment. And besides our own 2 employees based in the region, we have our local partners who are taking care for the day-to-day business together with our end customers. One of the local partners is Coast to Coast Technologies in South Africa on the left-hand side, and on the right-hand side you see SearchTech. They are also based in South Africa. And then on the lower line you see Amotech. They are based in Kenya, taking care for the East African business. And last but for sure not least, it's Quasar. They are taking care for the so-called Indian Ocean business. So Quasar is situated in Mauritius, taking care for the business there, but also in the Seychelles. So that was my try to explain the combination of, or the word of local, combination of 2 words, global and local. And with that, I'm handing over to, or back to Sylvia, I guess. Thank you so much.
Thank you very much, Daniel. At the end of this presentation, you will see the contact details of our Megger office, as well as the contact details of our official partners. Right now, I would like to hand over to Niklas Weatherstrand, our Business Development Director for Protection and Transformers. He will share with us the Megger focus in this area and other interesting projects we would like to share with you. Hi, Niklas. I pass the control over to you.
Hello, Sylvia, and hello, everybody. I hope you will see my screen soon.
We are looking at Teams screen now.
And now?
Yeah. Perfect.
Perfect. Good.
Yeah.
So thank you, everybody, for joining this third part of the conference. As Sylvia said, my name is Niklas Weatherstrand, and I work as a Business Development Director for the protection part of Megger. Protection in Megger is relay protection, obviously, but also the protection circuit, the circuit breakers and instrument transformers and testing of the full circuit, so-called primary injection. A few words of the future, and everybody hear the buzzword and the real word actually is smart grid. And what is that? There are actually descriptions out there. I think IEC has a good description of it. But there are a communication, IEC 61850, digital substation or digitizing the stuff we are working with. Distributed generation, renewable energy, and so on. And also I put in the word now digital twins. I change this every day for those of you who have been into this introduction. Today we're going to focus more on the digital substation stuff with the SMRT series. But for Megger, as I've told, is the 2 areas where we focus in the smart grid applications, and one is the digital substation, where we see more topics today, and also the distributed generation, where we had Stefan presented Wednesday regarding our solutions targeting that area. Furthermore, if you look into Megger organization, we are also active in a lot of committees and organizations which are working in this industry to make it more efficient and more reliable. So we have participation in IEC committees, in IEEE, NITA, SIGRE, and so on and so forth, and equal local organizations like that. This means that we work with the industry to develop with new methods and so on, and also to listen in to what the problems are and challenges out there with our customers. Of course, we are also tightly cooperating with the OEMs, the manufacturers of the assets we test. So you've seen all these names, ABB, GE, Schneider, but also local manufacturers of different assets. So it's not only these major ones, if you will. But of course, the operators of the networks are many times the main customer for us, since that's where the money, the electricity becomes the money, so to speak. And as you see, I've listed a lot of names here. Some of them are probably familiar to you and more local, but it's from all over the world. So we are active with these organizations to again improve and make things better for from a testing perspective and an operability perspective. Today, I also like to add some things for those of you who have been with us a few times. So can you confirm, Sylvia, that you see my web browser now?
Yes.
Okay, good. So I just wanted to add some things that we have on our website, a lot of information that you can find. And one of the interesting things is Electrical Tester Magazine, which you can find under Support Technical Library. And then you have two versions. One is online articles, but also actually the printed magazine, but you can read it online, so to speak. So let's see. Bear with me there. So this magazine do exist in a printed version as well. We have the front cover here. And it's, of course, technical articles, many times from Megger employee, but also what I would like to encourage to everybody is that we do it either as a combination with customers, or that even the customer themselves write something about the grid and futuristic stuff, or problems with challenges what we have seen. So this is actually an external article in the latest available issue about grid energy storage and so on. And if we go back, you can see in the table of content that we have some protection parts. We have end-to-end testing, line differential in this issue, for instance. But look in this, you will find many valuable things. And along those lines, I also want to share, and you will actually get the link to this document through the GoToWebinar somehow. This is a case study with regards to instrument transformer testing, something which is closely related to protection engineers. So I thought that could be beneficial for you. We have more of these kind of articles and case studies, and this again is something we are very happy to do together with you if there's a case where we can see that we have made a difference in the industry and want to share that news. Could be good promotion also for your company to see that you're thinking forefront and moving forward. So with those last words, I like to thank you everybody again for joining this Friday and hand over back to Sylvia.
Thank you very much, Niklas. And I shared already the link, so you can easily click on the link provided and you can download it and read the case study. It's a very fantastic piece of content, very useful, and you can be part of it. So everyone that is interested, please put in contact with us. So to continue with the presentation, today, we are ready now to start with the part 3. So let me share my full screen. Yes, you can see it, right?
Yes, we see your screen.
Thank you. This part 3, Megger and the SMRT family by Marius Spitzer. Marius has a large experience in relay protection. Marius started his career as an apprentice electrician in 1982, qualified in 1988, and worked his way up to become master artisan and later project manager for 132 33 kilovolts titanium smelters. Marius joined Megger in 2005 as a regional sales and application manager in South Africa, managing Sub-Saharan Africa. In 2015, Marius took on the position as regional sales manager for the Southeast region in the US, and in May of 2018, Marius was appointed as product manager for relay test equipment. Marius is really passionate about the Megger relay tested equipment and enjoys working with customers to find solutions to their daily challenges in using relay and high current test equipment. I'm Silvia Paulino, the Marketing Operations Manager for Europe and Africa, and I'm the organizer of this conference. Also, I will be supporting you with any technical issue and questions for our presenter. On the right side, you will see one screen that is similar to this one, and you can submit questions at any time during the presentation by typing in the box highlighted in red. I will read the questions and I will bring it to the presenter at the Q&A section. One question is frequently asked is if this webinar is going to be shared. And yes, this session is recorded, so it will be shared with all of you at the end. This is the agenda for today. Marius is going to talk about the full range of voltages, currents, NCAT Rogowski, computer driven, manually driven related sets, complex automated testing routines, user programmable, reporting, database handling, daisy chaining of test sets, AEC 61850 capabilities, technical documentation, papers, application notes available, training, remote training, and support. So, as we said in the past session, if you participated in 3 sessions, or at least in 2 of them, you will enter a special prize draw. So next week, we are going to publish the winner in LinkedIn. So be aware, be alert, and you will see who is the winner there. So said that, it's time to start. So Marius, thank you very much to be here today. Maybe very early morning in the USA, but we are really glad to have you here. So I pass the control over to you now.
Okay, can you see the screen, Sylvia?
Perfectly.
Okay, well, good morning, good afternoon, good evening, everybody from all over the globe. Sylvia did a good introduction, so I'm not going to talk about myself. Apart from that, I'll be presenting today. So I will step right into it. The agenda that might look a little bit different to what Sylvia had, but I am going to try to cover as much as possible, and I will ask your forgiveness in advance that I've got very little time and a lot of information to share. So if I do run through slides a little bit quick, please excuse me. Okay, so first of all, we are looking at the SMRT family of relay testing products. We've got a full lineup of SMRTs spanning from the single phase SMRT1 right up to multi-phase units like the SMRT 410 and 410D. Looking firstly at the SMRT1, it's a single channel unit which got 1 voltage, 1 current source. Current can go up to 60 amps at 300 VA for 1.5 seconds or 90 cycles. And continuous rating for the current channel is 32 amps at 200 VA. The voltage channel is 300 volts at 150 VA RMS. So what you can do with the SMRT1 is you can actually convert the voltage channel to become a current channel which will then give you an additional 15 amps at 150 VA for 1.5 seconds, or 5 amps at 150 VA continuous. And just as a note, these features rolls over to most of the other SMRTs in the SMRT family. Another excellent feature of not just the SMRT1, but the full range of SMRTs is that you can daisy chain units together. So in this case, you've got 3 SMRT1s daisy chained together to give you a multi-phase system. So you've got 3 currents, 3 voltages, or you can have up to 6 current channels. Moving on, looking at the SMRT 33, 43, 46, and 410, as well as the D models. And firstly, I'm going to talk about the 33. The 33 is an entry-level model 3-phase system, which still gives you the 3-phase voltages and 3-phase currents, maximum output of 32 amps, continuous, and 45 amps for 1.5 seconds. A note on this unit is that you can get up to 96 amps, 600 VA out of the unit if you combine the channels. And another note on this unit is that it does not have your a system board in the unit, so you don't have the option of additional binary inputs and outputs, or a battery simulator for powering up the relays. So moving on to the SMRT 43, which you'll get in the standalone unit or the display unit. And again, the specifications is very similar to what you've already seen with the other units. And the difference is that you've got a 4th voltage channel, which can give you 150 volt AC or 5 to 250 volt DC, which will simulate your battery simulator so you can power up the relays. Moving on from the 43 is the 46, and this is probably the most popular unit that we've got on the market today. The unit comes with 4 phase voltages, 3 by 300 volt AC or DC at 150 VA, and 1 by 150 volt AC or 5 to 250 volt DC. You've got 3 phase currents at a continuous rating of 32 amps, 200 VA, or up to 60 amps at 300 VA for 1.5 seconds. Your convertible channels, you've got the 3 channels that can convert to 5 amp continuous or 15 amps for 1.5 seconds to give you the option of having a 6 current channels in the box. The SMRT 410 is the top of the range. You get it up to 4 phase voltages, 0 to 300 volt AC DC at 150 VA, up to 6 phase currents with the same rating of 32 amps at 200 VA or 600 amps at 300 VA for 1.5 seconds. And obviously you can convert the channels as well to give you 10 up to 10 phase currents at 6 by 32 amps and 4 by 5 amps continuous. So this makes these units very flexible and to cover almost any application that is needed out there in the relay testing world. So all of these units in the clamshell and the SMRT1 can be controlled either via an SDBI, which is the Smart Touch View interface, or via a PC. Now, the same software that you can install on your PC will run on the SDBI. So you've got full control of the units with any automated test module that was created. As far as the SMRT1, if you use the SDBI on the SMRT1, you will need a Ethernet adapter, a power over Ethernet adapter to power up the SDBI to be able to control the SMRT1. Moving on To the display units, apart from the onboard display that you've got on the units, you can also control the unit from the PC, similar to the other units that I've already mentioned. Moving on from there, we're gonna look a little bit at the hardware capabilities of the SMRT family. First of all, you've got obviously the input power, which has got a universal power rating of 92 to 264 volts AC, single phase, and 47 to 63 hertz. Each unit comes standard with a safety ground receptacle where you can connect a safety ground to protect your equipment, as well as the on-off switch, which is illuminated to show you that your unit is on. Okay, moving on. First of all, in a 46 unit, you've got what we call 3 Vigens, and a Vigen is a voltage and a current generator. On the Vigen, the red channels, or the red side of the Vigen, is your voltage channels with, again, the maximum output of 300 volts and 150 VA, as shown in this red power curve. Several voltages can be connected in series to provide a higher voltage and power output, as shown as on the green curve on the screen. The voltage channels can be configured and used as current channels with, again, 5 amps continuous or 15 amps for 1.5 seconds. The yellow channels are current only, and the channels is maximum of 32 amps. And sorry, I missed something there. So 32 amps and an absolute maximum output of 60 amps. And again, to put these units in series, you can definitely achieve a higher output capability of these channels. Okay, moving on. We've got the 3 voltage channels, the 3 current channels, and we've got a voltage or battery simulator. Now, just as a note again, that not all of the units have the same battery simulators. Some of the units only have a DC supply, whereas some of the units will have the 4th voltage, which is the 0 to 150 volt AC, as well as the up to 250 volt DC. So this is the typical unit, which is the 4th channel. Like I mentioned, you've got selectable values of 24, 48, 125, and 250 volt DC, or it's variable, anything from 5 to 250 volt DC. It's got an output capability of 100 watts or 3.3 amps, so it can really power up a quite substantial relay with backup supply as well. And then, of course, the variable AC voltage of 0 to 150 volts, 100 VA. And as I mentioned there, it's unit dependent. There's just an image showing the different selections that can be made with the voltage. Okay, so moving on. On the side of the Vigens, you'll have an index number, and this index number, it actually references which channel you are talking about. So in this case, channel number 1. Communication, as I mentioned before, the units have Ethernet ports and several Ethernet ports, as a matter of fact, to provide communication, control, and for firmware upgrade of the unit. For non-display units, the port marked with SDBI should be used to connect an SDBI, since this port provides power to the SDBI over the Ethernet connection. Units also have Ethernet connection for a PC and 1 isolated Ethernet port for testing on IEC 61850 systems. The USB port is also a connection to PC, and it provides another form of control to the unit. A third option is an optional Bluetooth adapter that is provided with certain units to allow for wireless control using a PC. On the SDBI, you've got USB Type A ports that can be used for saving test report, test results, and templates, as well as for firmware upgrades. So you can transfer files from your PC to the SDBI or vice versa, and you can use these USB ports as to connect a USB mouse or a USB keyboard if you feel that makes it easier for you to use the SDBI. Okay, moving on. So on the SDBI, you've got a control knob provided, which can be used to ramp values up and down, as well as for navigating through the different screen options. And the next step is your binary inputs. So each unit comes with one, in the case of the SMRT1, or more binary inputs with a voltage rating of 0 to 300 volt AC or DC. You get up to 4 8-amp binary outputs and 2 1-amp high-speed binary outputs that can be provided as well. And this, again, is dependent on what unit you are working with. Then moving on, the unit has got an optional transducer input that can be provided, and these inputs can be used to test different types of voltage and current transducers using the appropriate forms in PowerDB. So you've got a DC in with a range of 0 to plus minus 10 volt DC, and a DC in amps, which ranges from 0 to plus minus 1 milliamp DC, or 4 to plus minus 20 milliamp DC. Okay, so again, like I said, I do apologize for running through this very quickly, but there's so much to cover on this, and talking about it in 45 minutes is almost impossible. So first of all, I'm going to, in this case, I'm going to talk about the software, and every SMRT purchased comes standard with the RTMS standard software. The RTMS standard includes the manual test screen or the home screen, simple and advanced ramp, pickup and timing of overcurrent, under voltage, and over voltage, plus directional overcurrent, sequence test for reclosing and transformer earth fault simulation, impedance, both generic and relay specific from various manufacturers, three-phase and single-phase current differential, and transducer and meter testing. Now, I'm going to go over these screens a little bit, not in much detail, but just to give you an idea of how powerful the software really is and what can be achieved if using this software. So first of all, looking at the home screen, the first is your pre-fault fault test. Now, pre-fault fault is very helpful when doing simple timing tests and fault finding on relays. This is especially helpful tool for the user who has to adjust mechanical contacts on electromechanical relays. The next one is the fault calculator. So the fault calculator is composed of the modes, fault type, and healthy values, fault values, output waveform, and percentage of harmonics. This will reveal a selection list for the different types of test options like overcurrent mode, voltage mode, frequency mode, impedance mode, symmetrical mode, power swing mode, and fault location mode. So very easy to set up a typical fault in the fault calculator and running it off the home screen to see how the relay will perform. Then the next one is moving on to the manual ramp. The manual ramp will present the user with a window to select the desired level of increment for manual ramping, the outputs, the desired channels to be ramped, and what is to be adjusted, whether it's the amplitude, the phase angle, or frequency. If using your PC, you can use the keyboard up and down arrow or even your mouse wheel to manually adjust the selected values at the desired increment level. Okay, moving on to the binary inputs and outputs. This selection will give you the access to the binary inputs and binary outputs of the respected unit. And the binary input has options for a dry or wet contact, as well as variable voltage threshold from 2 to 150 volts. And this specific feature, the variable voltage, is available on generator revisions 3.51 and higher. Okay, so then we move on to the connection button. The connection button will show you whether the SMRT is detected, and obviously it will, when you connect the unit and start up the software, it will automatically detect the unit and make connection with the system. If the background color is yellow, that indicates that the unit is online and ready for operation. And when connection is made, the background color will change from yellow to green to show that you are online or doing a test. Next, we've got the system configuration, and the system configuration will allow the user to configure the SMRT's hardware and RTMS software for items such as language, phase angle rotation, frequency selection, your battery simulator and voltage selection, voltage character and fault labels, and to view the current status of the SMRT firmware and hardware versions and RTMS software version, to name but a few. Moving on is the report options, and the report options button will present you with the test result in a report format. The report can be saved to the SDBI internal memory and transferred to PowerDB via USB memory stick, or when using a PC to the PC's internal memory. The relay settings button, the user can import or export information relative to the relay under test, such as manufacturer, model number, serial number, CT and PT information, etc., and in several different file formats like read from relay, import XREO, import TEAX files, import Schweitzer RDB text files, and importing of CSV files, and more. In the select new test window, this is where the RTMS test menu is in two sections, for standard and enhanced, and more on this later in the presentation. We move on to the relay library, and this button provides access to the relay test plans from different relay manufacturers. Relay tests are performed in accordance with the relay manufacturer's specifications. Moving on to the predefined test button. This button provides access to the predefined tests created by either Mega or the users in a PDB XML file structure. These test plans can be more generic or very specific, and the user can perform manual or automated tests, save them in the database, and then reselect them to reuse as a predefined test. The help button, this will provide help for both software and hardware, including a hardware system reset. And then lastly on this screen is the harmonic waveform, where users can define up to 4 waveforms. All 4 waveforms will be summed together to create a complex waveform from any or all of the selected outputs. If no value is entered for the second or third waveforms, then the output will simply be fundamental default frequency sine wave. So very powerful tool which will not require any lead changes or any hardware changes. It will run on the fly. All right, so moving on a little bit on the simple ramp. And the simple ramp is commonly used for doing pickup or dropout tests on any type of relay. The user may select voltage or current amplitude, phase, frequency, or symmetrical components. And the channel selection directly under the channel to ramp, and it also allows the user to select which channel will be ramped. So you've got, first of all, you've got a stair ramp, pulse ramp, and a binary search ramp. And finally, you can do up to 25 ramps on the simple ramp screen. Moving on to the advanced ramp. The advanced ramp has similarities to the simple ramp. Like in the simple ramp, up to 24 ramps may be selected, and the same with the advanced ramp. The primary differences between the simple and advanced ramp are the start and the increment and stop values, and addition of the smooth ramp. So first of all, you've got the pre-fault condition, then you've got your ramp start condition, you've got your ramp increment condition, and then your ramp end condition. The different type of ramps that can be performed is a smooth ramp, and the smooth ramp will output by applying a value based upon entry of an increment value over a time period. Then you've got the stair ramp, and you've also lastly got the pulse ramp. Moving on, and I'm just checking my time. Oh, I'm running out of time. The time overcurrent screen includes the options to do electromechanical relays, pickup test, and instantaneous pickup test. And the TOC screen allows the user to select up to 20 elements, and the curve selection has either ANSI, IEC, IEEE, standard time curves, as well as relay manufacturer specific curves. The sequence test is used for testing reclosing type relays, setting up multiple vectors and general multi-state sequencing. It also includes a transient earth fault simulation, including intermittent transients. So I'm sorry, but I'm speeding up a little bit just to get through most of my slides before Sylvia comes to kick me out. The next one is the impedance, and the impedance, for impedance, there are three methods provided in the RTMS software. The method providing the most flexibility and complete test capabilities, the click on fault. And then there's the second method, which is referred to as the EZZ, providing a more manual approach to the performing basic impedance relay test. And the third is for testing impedance relays with unknown or undefined characteristic. Included in the COF tool is an impedance relay library, which provides a selection window containing relay-specific impedance characteristics listed by relay manufacturer and model type. And also in the COF is the Mega Characteristics Editor, and this is a tool for creating impedance relay operating characteristics using a combination of lines, arcs, and or Mohs circles. And these impedance characteristics created using the MCE can be imported into the click on fault test screen, tested, and results can be saved. Okay, moving on to differential. Differential relay provides quick and easy approach to testing three-phase transformer, motor, generator, and single-phase transformer differential relays. In the settings screen of the differential test, the user can select the transformer primary and secondary winding configurations, enter the primary and secondary voltages ratings, CT ratios, transformer MVA rating, single-phase pickup factor, and much more, as well as relay specific settings. Typical test that is performed in differential is the stabilization test, timing test, pickup test, characteristic slope test, characteristic shot test, second harmonic block test, and the nth harmonic shot test. One additional feature is in the general settings section of the system configuration screen, there's a button labeled multi-instances. And this button allows the user to select multiple differential relays to test and combine into one test result file. Then we've got the transducer test, which I covered a little bit, but in conjunction with the transducer hardware option in the SMRT, the transducer test provides a quick approach to testing all types of single-phase and three-phase electrical transducers. The meter test provides a quick and easy approach to testing the metering function of protection relays. The user will simply select the output channel similar to the manual vector screen, and the values will be in secondary, default or primary by clicking on the different ratios. Okay, then we move on to the enhanced version of the software, which includes the synchronizer, under-over, and rock-off for frequency relays, IEC and IEEE contract transient waveform playback, power swing, SS1 file converter, and the IEC 61850 Mega Goose configurator. So very quickly, the synchronizer, first of all, the synchronizer, and then the, oh, I think I've messed up my screens, but the frequency test, you can perform the under frequency, over frequency, and rate of change in the frequency tests. Moving on to ComTrade, the ComTrade test option provides the capability of playing back transient waveform data from the SMRT relay test system. In other words, it can recreate a fault recorded by a digital fault recorder, protective relays, or a simulated fault using software tools like EMTP, ATP programs. Then power swing. The power swing simulation tool is similar to the power swing tool in the fault calculator, and the power swing simulation tool uses two superimposing waveforms of similar frequencies to provide a smooth impedance ramp. Moving on to the SS1 file converter. This file playback is used for importing a state sequence files from Aspen and Cape power system simulation software programs. By modeling the power system using Aspen or Cape, the relay can be tested dynamically using realistic system test scenarios. So using the SS1 file data, RTMS software will automatically create a sequence test, and the test currents, voltages, and phase angles and wait times defined in the SS1 file will appear in the sequence test screen. And there are three modes to select from, which is run immediately, wait on REC-B, and wait on a contact. Moving on to the Mega Goose configurator, and the Mega Goose configurator software provides mapping of the binary inputs and outputs of the SMRT test set to the desired Goose messages. The Goose messages are read from an available SCL substation configuration language file, or may be automatically detected by scanning the substation network in search of an available published Goose message. The scanning process is known as Goose sniffing, and the MGC also provides advanced network troubleshooting tasks, such as comparing the Goose messages available on the network with the Goose messages described in the SCL files with Goose merge compare functionality. Okay, moving on. Sampled values, and the mega sampled values is in compliance with 61859-2 LE, where we can provide 3 streams at 50 or 60 Hertz, 80 sample profile, and we fully map 4 voltages and 4 currents. Waveform analysis of published SV streams at 10 seconds trailing capture. Merging unit testing ability is possible with SCL import. So what's new on the Mega front? And the new is Rogowski mode, and this will change your current channel from a current source to a voltage source. And this will allow the current channel to simulate a low-level voltage source from a Rogowski coil. On the Mega MLLF, we've got a 2, a 10, and a 40 volt range. Okay, moving on special features like daisy chaining of units. You can daisy chain up to 5 SMRT 46s, which will then provide you with 15 current channels and up to 20 voltage channels. And the voltage channels can be converted to current to give you up to 30 current channels for testing bus differential schemes. Then just a little bit on information. So the Mega YouTube videos, there is a lot of videos available on RTMS and the SMRT on different functions, whether it's transformer differential, whether it's setting up a ramp test, how to use the test library. So there's lots of different videos. So I would encourage you all to please go and look at this, and if you've got any other questions. So what's in the future? We can ask the question, virtual testing of protection relays. Niklas mentioned something earlier on. A digital twin. What is a digital twin? A digital twin is simply the name given to a virtual replica of an asset. Can Mega do this? How can this be done? Maybe Andrea can help us on this one. Sylvia, can we switch over to Andrea?
Yes. We can see your slide, Andrea.
Thank you. Thank you, Marius. Yes, thank you. Very nice presentation, very interesting. I have now the honor to introduce you for the first time to a digital twin for a relay test set. But we must start for a digital twin for a protection relay, Cyprotec 5 protection devices that have developed a completely full digital twin. So which is a replica, software replica of the protection algorithms into the physical relay. And we have done a digital twin for our relay test set, SMRT series. So the blue one is actually the ghost of the real test set. So in RTMS software, when we can connect, it's asking us to connect to the real test set, we can eventually simulate the device, which is something between 50-50 between a real relay and the simulation world. It's not this I want to talk about. We can connect it to a real test set, or now we can connect to a digital twin. So where it's a replica inside the computer, we have a replica, fully replica of the test set, and there is a full dialogue between the software and the digital twin. And here you have the relays we can choose under digital twin mode. So what can we do with them? I'm not going to go in many details about that. We will launch soon the process, the idea. But if a digital twin relay can talk to a digital twin test set, then we can have the so-called virtual testing. And there are a lot of tests we can do in the virtual world without that we need to do them in the physical world. For example, setting groups, 1, 2, 3, 4, 5, 6, 7 setting groups. We want to test all of them, and we don't need really the physical contact connect to the test set. We can look in the event recorder what happens and decide if it is good, and find a lot of mistakes in the settings, in the configuration, in the logic, in the compilation, etc. So we know that it's a good idea, and it can work very well. Advantages are several people can work in parallel, and then the red ones I take the last. The expertise is available in the company in case of trouble, so you can ask immediately your colleagues. We have a more comfortable environment, we have less time pressure for testing, and you can do the work on your time, even in the evening. Geographical barriers are eliminated. Think about line differential protection when you have both relays, virtual relays on your computer, and you can test them without having the connection physically done. And also complex tests, because we can have a virtual super test set that can have you 20 feeders with the 60 currents, which doesn't exist in the reality, even if we can daisy chain our test sets, and then you can perform some tests that you might not even think to perform in the physical situation. All of this is important because when you do these tests, you validate your software for the relay software, relay settings, so relay configuration, and the relay files can be used in the substation. Also, the relay test set files saved can be used in the substation, when instead I will connect to the physical test set. So when you are in the substation and commission, you know that things should already work because you tested them in the digital twin in the virtual world. This is a very powerful position, because normally when we do commissioning, we have no idea if it works or not. We start from scratch all the time. Here you can say, no, well, last month at home it was working. Why it doesn't work here? And you can pinpoint where to go. Then at the end, what does it mean? Sort of vision, of course, a commissioning virtual test, which we do on the virtual world. Then we have to do a subset of them can be the number of tests I do physically in the substation, because the contact, the Goose method must be tested to the breaker, and to other relays must be tested there. So, but they are limited. Of course, you are always surprised, so you can have some other new tests that you must do in the substation, of course. But before, all of these tests were done on site and almost from scratch. So the idea is that in the commissioning, we do a subset of the tests we did in the virtual world. We will have soon an article on our Electrical Tester magazine, virtual tests on the protection relay. So for the moment, I cannot say more than that. And I say thank you for your attention. And I'm done for that. And I give back the word and the screen to Silvia, I guess. Or to Marius.
Thank you so much, Andrea. Thank you so much. A lot of news, a lot of interesting content. And Marius, thank you so much for everything that you have been explaining. And the complexity of relay protection is high, but we have many questions. I have to say as well to Niklas that we have already people asking for case studies. So to be part of this project, and this is fantastic. And if you want, I can read some of them. We will extend a little this session, 5 minutes more, a little more if it is necessary, to answer a couple of questions. For example, what is used to synchronize SV during the injection? Is it external PTP, receiver, antenna? Thanks.
I'll leave that to you, Andrea, as you are the specialist there. Yeah.
Yes, at the moment we have a 1 pass per second, which is incorrect, done according to light edition standard. But there are PTP possibilities. We can have a PTP converter from PTP to 1 PPS. But at the moment, it's the device is in pass per second.
Okay. Can we get link of videos of Micron P654X and Siemens 7UT87 relay testing? Maybe we can go deeper afterward, but if you can answer now.
No, I don't. What did you say? Can you say again?
I think are asking about link videos of Micron P64X and Siemens. I believe they are relays.
Right. So I don't think that we've got specific relays for the Micron P54X or the Siemens 7UT87. I don't think so, but I can definitely check on that, and we could respond afterwards, Sylvia.
Okay. Another question is if, along with the SMRT, Marius, do they have AEC 61859-2?
Yes, we have 61859-2 LE, as mentioned in the presentation.
Okay. Another question, do you have relay test plans ready for new relays from different manufacturers?
Yes, we do have. And we are adding on a daily basis. We're adding more relay test plans, but to answer the question, and it depends on what relay you're referring to, but we definitely have test plans for new relays and old relays as well as electromechanical relays.
Mm-hmm. Here, there is a question to demonstrate how to use ComTrade function in RTMS. So maybe this is possible.
I'm not sure, and again, I can check on the mega videos if there is a specific one on ComTrade. There could be, but that is definitely possible to show a video of how to use the ComTrade function.
All right. We have another question. If it is possible to use two SMRT1 to test differential relays?
Definitely. So if you use a single SMRT1, you can convert the voltage channel to current and you can test differential single phase. Or if you daisy chain up to 3 SMRT1s, it then becomes a 3-phase system, and you can test normal differential with 6 current channels if you convert the voltage channels.
Okay. Could you again repeat the importance to have right now a Rogowski coil function in our test products now in SMRT?
So I don't quite understand the question, but yes, definitely the new hardware in the SMRT units can definitely support Rogowski. And as I mentioned in my presentation, together with that is the MLLF, which is the low-level filter that just filters out the noise so you can test Rogowski capability. So your current channel will be converted to voltage to give you the low voltage outputs needed for these Rogowski coils.
Yeah, I think it was answered before, but it was good to highlight again that we are including this test.
Silvia, maybe I can add, Marius, that we support all the standardized ranges of the Rogowski coils from the smaller level to, I think it was the highest level is 20 volt or 40 volts, I don't remember.
Yes, 40 volts, yes.
40 volts.
Yeah, because there is certain relay OEMs that need, that's got very high fault currents, and that's what we need to simulate up to 40 volts.
With the same accuracy.
Yep.
We give it.
Yep, same accuracy.
Another question is if we can test with the SMRT test trouble wave relays.
Well, I can say Potentially, yes.
That's traveling ways.
Is it a function that we've implemented? And then that answer is no, not yet. It is, however, on our roadmap to include traveling wave at some point. What we have done in the past is we've worked with Schweitzer on their system and using their traveling wave converter to test with our units, which was not a problem. But at this point, we don't have a full solution for traveling wave.
Okay. There are a couple of more. So the last two. And anyway, they will be answered properly if you want directly. For example, what are the tips for apparent impedance dynamics test for distance relays?
Sorry, I didn't get that one. Sorry.
Yeah, it's difficult. But what are the tips for apparent impedance dynamics test in the case of distance relays?
I think I can take that. I think its meaning is apparent impedance, distance protection, dynamic test. The key for our tools is simulation, power system simulation method, which for us it means actually ComTrade. So we don't have a real-time system. We are not able to simulate the breaker when it opens, etc. But for many tests, not all of them, but for many tests, it's enough to re-simulate, to re-inject the ComTrade file that is generated by real-time system or of not real-time system, but the power system simulator anyway. I think this is a question, I hope.
And the last one for now, will SMRT saves our testing time of relay?
Yeah, absolutely. I mean, in any of the test options, whether it's timed overcurrent, impedance, differential, your time is definitely saved, and it will be saved in a report if the customer wishes to do so.
Okay. Anything then you would like to add to this last part of our fantastic digital conference? Any of you?
Well, I just want to say thank you to everybody. First of all, Sylvia, you and the team for making this happen, and then for all the attendees that attended the 3 different sessions. And we know that 45 minutes is a very short time to talk about relay protection. So if there's any other questions or queries regarding any of the sessions, please reach out to your local representative. And certainly we will definitely want to answer your questions or come back with some sort of a response. Thank you.
Okay. So thank you so much to everyone. And only one more thing. Here you can see the contact details of our official partners. And please keep note. And right now, it's important for us to continue improve. And you will see a final survey. There you can put your questions and comments and even answer the questions that are preset there for us to make it a more interactive, to do it much better anytime. So thank you very, very much. We are here to help you, and have a fantastic day and weekend and the next week as well. Okay.
Thank you so much.
Thank you very much.
Thank you.
Take care.
Bye-bye. Thank you very much all over the world.
Bye-bye.
Bye.